Welcome to Module 6 in our series on 279W Windows Server Administration. I am your instructor, Robert McMillen, and we're going to be discussing storage on this particular module. So before we get started, I'd like you to go into your VMware player and shut down your server, and then right-click and go to Settings. This only works if it's shut down. Go to your hard disk. Then go ahead and click on Utilities. Click on Expand. And from here, you can make that anything larger than the original size that you created it. I'm going to make it 75. Click Expand. Click OK. Click OK. And then go ahead and restart your virtual machine. So while we're waiting for that to restart, we'll go ahead and continue on. Our objectives will be data storage, storage management, disk management, basic and dynamic disks, and encrypting file systems. Also talk about trusted platform module, BitLocker, fat volumes, new technology file system or NTFS, and disk quotas. So under data storage, one of the popular types of data storage is network attached storage. This is a really simple type of a storage. It tends to be inexpensive. It is a box of hard drives with a very simple operating system on it. It could have a Windows operating system, but more likely it'll have a Linux operating system on it. So you connect to it using just TCP/IP. All server storage communications go across the organization's LAN. Bandwidth on the network can be shared by clients, servers, and NAS devices. So what this is this is just a box for you to attach to your network to share files. That's what network attached storage is. It has its own operating system on the box, and you can typically pick one up anywhere from $100 all the way up into several $1,000s, depending on how much storage you want on that particular server. A SAN is much different than a network attached storage. This is storage area network. So what this is, it's physically separate from the LAN and is independently managed. Server to storage communication doesn't affect the clients and server communications. So what this is, instead of a box with its own operating system on it with hard drives that you can only share folders on it, this is an actual Windows server. It's a Windows server. You can install applications, SQL, Exchange, any other application you would like to put on it. And it has an attached box to it that is a box of hard drives. So this box of hard drives expands the amount of storage a server can have, and you can connect to it either using a fiber cable or an internet cable. iSCSI is what it's called, communicating over TCP/IP. SCSI cable. There's many different mediums that you can connect to this box. The box itself does not have an operating system on it, and it's simply used to expand storage to a server that you already have. Under storage management, this is something we talked about in previous modules, was volume shadow copy service, which allows you to create point-in-time copies. I walked you through that, as well as DFS, which allows you to create a single directory tree that includes multiple file servers and their file shares. This is all managed. You can manage this under storage management. And FRS, which of course is the replication between domain controllers. So in order to install and configure file services, the file servers provide the central locations for storing and sharing files across the network, so you need to install the file service. When many users require access to the same files and application data, you'll need to configure file servers throughout the organization. So as we talked about previously, there's DFS and the different components of DFS. The primary tool to manage storage is the Disk Management tool. It is a snap-in included in Computer Management and Server Manager. And it can be added to any custom MMC you create as well. So in the MMC module we did previously, you can add in Storage Manager there. Two different types of disks you can create. One is the basic disk, which is created by default. It uses the same disk structure as earlier versions of Windows. It's limited to creating 4 primary partitions per disk or 3 primary partitions and 1 extended partition. So this is the default that you get when you first put a drive in. However, you can convert the basic disk into a dynamic disk. And these came out with Windows 2000, so a while back. And it allows you to create and manage disks without having to restart the server as often whenever you make configuration changes. You can also create fault-tolerant disks, such as a RAID configuration. We call this a software RAID because it's being done in Windows itself. You can no longer do a software RAID configuration using the system disk. You'd have to do a hardware RAID to do that because Microsoft no longer supports it. They had way too many problems with it. All volumes on dynamic disks are known as volumes. So you actually, when you upgrade a dynamic disk to be a dynamic disk from BASIC, you now refer to them as a volume. So there are simple volumes, which is a volume on a single drive and has the same purpose as a primary partition. The space allocated for such a volume would be contiguous. Spanned volumes, that's a volume that spans multiple drives. So this would be you could have one drive lead right into the next and into the next. So some people refer to this as a JBOD, or just a bunch of disks. Striped volumes requires that all the drives be exactly the same size. A volume that uses RAID 0 to combine multiple disks into a striped set. Now, none of these have any kind of fault tolerance, so if one drive fails, the entire volume fails. Here's where you have the drives that do have redundancy. One of them is a mirrored volume, so that is also referred to as RAID 1. So if data is written to one drive, it's mirrored to the other drive. Another type of dynamic volume would be RAID 5, where you need a minimum of 3 drives, and it creates a striped set just as RAID 0 does, but it also puts on parity, which adds redundancy to that, which is explained very well in the book, so we won't get into it here. Encrypting file system. You'll be doing this in your lab. You'll be setting up encryption on a file for encrypting files and folders. Users can protect sensitive data so it can be accessed using their public key certificate, which you have installed by default when you create the Windows server. Encryption certificates are stored as part of the data in a user's profile. It doesn't safeguard the computer from attack by someone who has direct physical access. So if anyone else logs in as the administrator, they'll be able to decrypt it by default. If they're not logged in as an administrator, then they will not be able to. A trusted platform module, this is a special microchip that is usually installed on the motherboard. Computers running Server 2008 can use a TPM to provide enhanced protection for data, to ensure early validation of the boot file's integrity, and to guarantee that a disk has not been tampered with while the operating system was offline. So what a TPM does, it has a little chip on the motherboard, and you link this chip through a software program in Windows that basically encrypts all the data on the hard drive and protects it from being tampered with. If a server does not have a TPM on it, and not all motherboards have them, then it's not a problem. You can still do software encryption, but having a TPM allows you to do hardware encryption, which is even more secure. So if a hacker comes in physically to your place and breaks in and just steals the hard drives, if your server is configured to use the TPM, those hard drives will be unusable and they will not be able to get any data off of them. BitLocker, it can also work with a TPM or without. It is software drive encryption. So EFS, which we talked about 2 slides ago, was just for encrypting files and folders. BitLocker will encrypt the entire hard drive. So if the hard drive is lost, stolen, or decommissioned, the data will be encrypted and your data will be safe. So without BitLocker drive encryption, there's a variety of ways a user with direct physical access to a computer could gain full control and then access the computer's data, whether that data was encrypted with EFS or not. But using the BitLocker protects you against all those kinds of things by any unauthorized personnel. So there's more than one volume, and FAT volumes were used years ago, but in some cases you still want to use FAT volumes, and I'll tell you why. So let's talk about what FAT is. Yeah, it uses an allocation table to store information about the disk space allocation. File allocation table is what FAT stands for, and it has the following disadvantages. You can't control local access to files and folders using Windows file and folder access permissions. You can't use any advanced file system features of NTFS, including compression, encryption, quotas, all these types of things. You can't do it with a FAT volume. So the alternative, of course, is NTFS, which is an extensible file system. It means it can be expanded and changed over time. Instead of a file allocation table, NTFS uses a relational database. This relational database allows the master file table to store information about the files. The master file table stores a file record of each file and folder on the volume, pertinent volume information, and details on MFT itself. So you have the following capabilities. You can use advanced file and folder access permissions. You can use file sharing and full control remote access to files and folders. You can use long file names, which is nice. You can go longer than just the old requirements of the 8.3, meaning file and folder names can be up to 255 characters. And you can use Unicode characters, which you could not use in a FAT name. And a Unicode character, could be something other than a letter or a number. You can use uppercase and lowercase numbers. You couldn't do that with FAT. And you can't use NTFS with floppy disks, but you can use NTFS with removable disks, such as zip drives. So why would someone want to use a FAT file allocation table type of a drive rather than using NTFS? Well, it's if you want to communicate with other devices, such as a Macintosh. So if you wanted to copy files onto a thumb drive or a USB drive and then copy them again over to a Macintosh, it doesn't understand NTFS. It does, however, understand FAT. So that's one really good reason to understand how to format a drive with FAT and how to use it. So let's go back to our server now that it's been rebooted after we went in and expanded the hard drive. And in your lab, you will need to do this ahead of time so you can do your lab properly. So let's go to Server Manager. And we originally formatted our C drive. We'll click on Storage with a 25 gigabyte drive. So now we see our 25 gigabyte C drive, but since we expanded the drive, we now also see a 50 gigabyte drive on top of it. So we're going to create a new volume. This will be something you do in your lab. So a new simple volume. We'll go ahead and use the whole thing. We'll let it assign a drive letter. Here's where we have some options. We can either not format the drive, which will make, of course, the drive unusable, but we can format it at a future time, or we can format it with either NTFS or with FAT. So we can choose the standard size allocation unit, or we can choose something different. I would choose the default. You really have to understand what those are for before you choose something else. And you always want to perform a quick format unless you have all day to sit around, because formatting drives does take forever. When you don't do a quick format, it actually checks every single sector for any kind of a problem. And you can do that kind of check when you're not quite as busy, maybe overnight, that kind of thing. You don't want to do it right now. And you can also compress the folder if you want to make a 50 gigabyte drive somewhere around a 100 gigabyte drive, then you would click the compression. So we're going to choose these particular options. Click Next, click Finish, and now you see the 50 gigabyte drive formatting, and now you see the drive letter being applied. And if we go into Explorer, we now see the drive is usable. And we can go ahead and add a file to it if we want. There you go. One of the other things you'll be doing in the lab is you'll be adding the Windows backup role. So we're going to go ahead and choose Add Roles, Next, and we're going to choose the Windows backup. I apologize, I meant the features. So you'll see Windows Server Backup Features. We'll go ahead and click Next, and we'll click Install. And then once the backup is there, we'll be able to open it up and use it. And you'll be using this in your lab. So we'll click Start, Administrative Tools, Windows Server Backup. Now we're going to use that new drive that we created earlier to be our backup drive. And you will be prompted to run a backup. So we'll just do that backup once. And we'll just go ahead and choose under different options, which is our default. We can choose the full server or we can choose custom. I'll choose custom just for this particular one. We'll go ahead and add items. I'm just going to choose a particular folder, although you'll be doing something different. And I'll choose next, and it'll say, hey, where do you want to back this up to? And I'm going to say a local drive. And we're going to choose the E drive, which it finds by default. Next, and then backup. So that's how you install backup. That's how you use backup. Of course, your backup will take a while longer because you're going to be doing something different than what I just did. You'll be backing up the whole C drive. And that'll probably take anywhere from 15 to 30 minutes, depending on how fast your computer is. And then when it's done, this is going to show me that I had a successful backup. Okay, in conclusion, we discussed data storage, storage management, disk management, basic and dynamic disks, EFS, TPM, BitLocker, FAT, NTFS, disk quotas, and showed you how to install and use Windows Server Backup. That concludes this particular module, Module 6, and we look forward to Module 7, where we'll have new things to discuss.